and welcome to today's session. Glad that you are here today. Thanks so much for joining us. We have a fun little journey ahead of us in today's session titled Compose Multi-Platform iOS, Android, and Desktop Apps in 100% Kotlin. Um, Throughout this session, we're going to see how Compose Multi-Platform equips you with a couple of new superpowers when it comes to building shared user interfaces that work on Android, iOS, desktop, and beyond. Before we dive into this, though, just a tiny smidge of housekeeping. We will have a Q&A at the end of this presentation. And this whole thing is also being recorded for your viewing pleasure at a later point. Before we dive in, let me just briefly introduce ourselves. My name is Sebastian. I'm one of the developer advocates at JetBrains, focusing on Kotlin and Compose multi-platform. And I am joined today by my lovely colleague Martin.
Hello, I am also a developer advocate for Kotlin, focusing on multi-platform.
Look at that, easy to remember. So we have a lot of things to get through. So let's kind of dive right in. We are going to discuss a little bit today about what Compose multi-platform is. We're going to take a closer look at the different targets we have for Compose multi-platform, as well as their stability levels. Then in the middle of the presentation, we'll have a rather expansive live demo where we'll build a small application from scratch from 0 to 100 with Compose multi-platform. After that, we'll also dive into a couple of more advanced Compose multi-platform topics, given that we're hopefully all sufficiently motivated by that point to dive into those. Also, see a couple more details on Compose for iOS specifically, since those questions always love to come up, and we'll take a look into the future of what's next. So in the process, we'll build a small but fully functioning application that will consume data from an API and display it on all the platforms that we target, which in our case is desktop, Android, and iOS. We'll make use of Compose multi-platform to build the UI in a shared fashion so that we don't have to build three UIs. We only have to do everything once. Now, before we get into this, though, it would probably make sense to get a better understanding of what Compose multi-platform is all about.
Right, so if you haven't encountered it yet, Compose Multiplatform is a multi-platform UI framework by JetBrains. It's built on top of Google's Jetpack Compose, which is a UI toolkit for Android, and expands it with additional platforms. So you can write your UI code once and run the same UI on different platforms. The currently available platforms are the ones that you can see on the slide here. So we've announced iOS support earlier this year. That's currently in alpha. Android is stable because on Android, Compose multi-platform is Jetpack Compose. We also already have stable support on desktop, where you can use Compose multi-platform to build Windows, macOS, and Linux applications for desktop. And this target actually already has more than 1 million end users, as JetBrains Toolbox is built using the technology. So if you use that, you're already a happy user, hopefully, of Compose multi-platform. And finally, we have a web target here, which is experimental. And we do encourage you to already try that out, because that's also going to be really exciting. If you are already familiar with Jetpack Compose APIs from Android, you'll feel right at home with Compose multi-platform APIs, as the APIs for the most part are exactly the same between these two toolkits. Basically, Compose multi-platform APIs are the Jetpack Compose APIs minus some super Android specific parts, and plus some things to support the other platforms like iOS and desktop specific things. The great thing about this is that if you have existing knowledge of using Jetpack Compose, that knowledge will transfer over great to multi-platform, because creating layouts, doing styling, doing animations, all of these things work the exact same way. Another nice benefit is that all of the learning resources that exist for Jetpack Compose can be reused to learn Compose multi-platform. So for example, you can go to all of the documentation that Google has for Jetpack Compose, learn about things like the foundational mechanisms of Compose, and you can use that in Compose Multiplatform as well. Now, next up, we want to take a look at an example of what an app might look like that adopts Compose Multiplatform. Here we have a sketch of an application which is targeting iOS and Android. It has a big chunk of shared business logic there in the middle, which uses Kotlin multiplatform for sharing, and it also has some platform-specific logic in it, as well as fully native platform-specific UI implementations. So on the Android side, we can see that we have a Jetpack Compose implementation potentially interoperating with Android views, and then on this on the iOS and Swift side, we see that we have Swift UI and or UIKit as the implementation. So we already have shared logic here, but if we also add Compose Multiplatform to this scenario, we can also start sharing the UI. Just like with Kotlin Multiplatform in general, adopting Compose Multiplatform is all optional. So it's up to you whether or not you want to have shared UI in your application. And once you decide to use Compose Multiplatform, you can pick and choose when you share UI and when you don't. So you could, for example, pick on a screen-by-screen basis of whether you want native or shared UI. Now, you can also extend this with other platforms, as we've mentioned previously. For example, if you have an app like this, which had the two mobile targets, you could also then fairly easily add a desktop target to it as well, which again uses shared business logic as well as shared UI from Compose. And that brings us to our sample app today.
Awesome. So now that we've gotten a bit of an overview, I think it's time we get our hands dirty and see what this kind of stuff looks like in code. Because at least for me, I'm always a visual learner. I like seeing how these things work in practice. So what we are going to construct is our small little bird application. It's not going to be particularly complex architecture or layout wise, but here's kind of the high level view of what we're going to do. We have some kind of API that gives us back JSON information about images. About bird images. Those will funnel through our view model, which is associated with the actual UI that we'll implement. As you've seen in the previous screenshots, this UI is not particularly difficult. We just have a column of items where at the top we have a row of buttons that allow us to select a specific category of bird. And then at the bottom, we'll have a scrollable grid of different images. And we'll realize this in Compose Multiplatform. So with that, we can leave our presentation and start with doing some actual hands-on project work. The best way to get started with Compose Multiplatform projects is via the Kotlin Multiplatform wizard, which you can find on kmp.jetbrains.com. Here we have a couple of different options. We'll set this up as we go along. Our first step is calling this thing a certain project name. I'll call it My Bird App, and I already have the project ID JetBrains My Bird App set up. Whether you're using Compose Multiplatform or not doesn't actually matter that much if you're using this wizard, because you kind of get to pick and choose everything that you want to do. So on Android, we do use Compose, and then we also add the iOS target, and we'll select Share UI because we do want to use Compose Multiplatform today. If you were to not want to do that, you can also use Swift UI and just set that up in the wizard accordingly. We'll also have a desktop target because that's what we showed in the screenshots, so it makes sense to also have it here. We could, in theory, at some point in the future, then also add a Kotlin for WebAssembly target here as well. This isn't quite ready yet, but it is in the works. If you're interested in the subject, you can, of course, sign up for the live session that will be coming up in December called Kotlin and WebAssembly Unleashing Cross-Platform Power, where you'll see a little bit more about that. From here, it's as easy as hitting the download button and actually just taking this zip file, unzipping it, and then opening it in an IDE of your choice. We are going to use Fleet today, but I just want to also let you know that you can open the same project in Android Studio, for example, as well. For the best experience when working in Kotlin multi-platform projects, make sure that you have the Kotlin multi-platform plugin installed as well. Today, because we will be working together and we love trying out new and shiny toys, however, we'll be opening the project in Fleet, which looks like this. In case you haven't seen our announcement about Fleet yet, Fleet recently has gotten new superpowers for working with Kotlin multi-platform applications. So we're, of course, very giddy to show this off. One of the very nice parts about this is that we also have collaboration right built into Fleet. So I can start a session here, and then I will send the link of this session to Martin, who can open the same session on his machine. I have done that in our private chat over here. And then after just a couple of seconds, Martin should probably show up with a join request. Here he is. So I'll just approve his access, and we can see that he has joined me. So first things first, before we dive into doing some actual development, though, I think it makes sense to make sure that our development setup is set up correctly. So let me just make sure that I have the KDoctor utility installed, which is a tool for checking out your environment and making sure that everything is set up correctly and you're ready for multi-platform development. You can see that mine is already set up, so I can just run KDoctor, and this will tell me that everything I need to work with Kotlin multi-platform and Compose multi-platform is available on my system. If something was missing or misconfigured, then KDoctor would let me know and would also give me a couple of useful hints as to how to fix these things. So now that we have started with this, I think we can get started with our actual work. We can start, of course, just so that we have some kind of checkpoint by initializing a Git repository and adding everything in an initial commit. So I'll just do that real quick. And from here, we can actually start our real development work. So we have a couple of different things that we will need to do. We have an API endpoint. Let me just zoom this in a little bit, which will give us back a couple of different JSON objects. And each of these JSON objects describes a bird image. So it has a path. If you visit this path, you come to the actual image of that bird. It also defines a category and an author. So we'll have to somehow thread all this information through our application and make sure that it eventually lands in the user interface. All right. So, Martin, I see you're already in our version catalog here.
Indeed. So we'll use a handful of dependencies in order to build our app. So the nice way to do that in an app that's generated by the wizard, which has a version catalog, is to actually use the version catalog and add the dependencies in there. So I'll start by adding the actual versions. You can see that we'll have three groups of dependencies here. We'll use Ktor to provide us with networking. We'll use Moco MVVM to have a multi-platform view model implementation. And we'll use Camel so that we can actually display our beautiful images of birds. Having the version set up, we'll now scroll down and add the dependencies. Again, these are from the three groups that I've mentioned before. You can see that, for example, for Ktor, we have a handful of dependencies here, including the core, as well as some dependencies to support JSON parsing using Kotlin X serialization. We also need to add a plugin for that, which we add down here at the bottom in the plugins block like this. Having added these to the version catalog, we can now hop over to the build.gradle file for our Compose app module so that we can actually add these dependencies. So we'll start at the top here by adding the Kotlin X serialization plugin like such. And then we'll scroll down to the source set configurations. We have a common main block here, which is the block where we can add dependencies which are multi-platform that are usable from common code. So we'll add all of our Ktor things here, the Moco MVVM libraries core, as well as Compose specific support and Camel. And all that we need to add for the platform specific dependency blocks is the engine that Ktor will use, as that's platform dependent. So for Android and for desktop, we'll use the OKHTTP engine, which is a very popular and well-used library for the JVM. And for the iOS side, we have a Darwin-based engine, which you can use on Apple platforms. And I think with that, we have all of our dependencies set, and we should be able to start getting ready to fetch our data.
That's great. I'm always someone who likes to make double sure that the things we do actually work properly, so we can just start this on one of the supported platforms, for example, desktop. So we'll do that for a second. And we can indeed see that we get kind of a bit of a scaffolding here. We can press this button, and we get a nice little animated view of the UI. And Martin here in the background has luckily already moved my code or moved my view over here so that we can see the code that's actually working along in question here. And of course, this would also work for the other platforms. We'll take a look at those in a little bit. Great. So with that, we can move on and we can start by defining, first of all, our data model. So that's how we get the actual data into our application, and then we'll define a little bit of like HTTP client work through our view model that does all this kind of work. So let me just start by creating a bird image class, or a bird image file, which is supposed to encode one of these JSON objects. We are using Kotlin X serialization, which makes it really easy to take data classes and turn them into JSON, as well as the other way around. So there's, of course, a bunch of different ways of how you can do this. Like you could use, for example, some kind of converter tools. I am just going to use the integrated AI assistant in Fleet. So I will just ask it to write a Kotlin data class for this JSON. I'll paste in the JSON, and I'll give it a couple of seconds, which gives me a bird image class, which, as you can see, has the same properties as our JSON object. So I can just accept this, and all that's left for me to do is to add the serializable annotation from Kotlin X serialization, and that is our data model done. With that, we can move on and actually build our view model. So we'll call this the birds view model. And from a very basic scaffolding perspective, this just means that we will create a class, which is a birds view model, which implements view model. You can see that this is not anything from Android specifically, but it uses the Moco MVVM view model. I already saw the question pop up in the chat here. There are different cross-platform implementations of view model. We just happen to choose this one. You can, of course, use other ones. And we'll also talk a little bit more about what kind of libraries for example, navigation are available in a little bit.
Yeah,
great.
And the same applies to things like image loading. We have to pick a library that does it, but there are multiple great libraries in the community to do that. So we're just picking one because we have to.
That's right. Great. So we already have Ktor available in our project thanks to Martin's dependency declarations. So I can just create myself a private HTTP client, which is just a new HTTP client with the default engine inside it. Because we are working with JSON, we want to use the content negotiation integration, which is as easy as writing install content negotiation and then telling it to use JSON. And now we've kind of clicked the blocks together of Kotlin X serialization, Ktor's HTTP client, and so on. So this is kind of the most basic thing that we need here. Now I'm thinking we can probably just quickly write out the function that makes the actual HTTP request. And then from there, we can kind of work through how we would manage state in Compose, Multiplatform, and actually get a first response, like a first HTTP response on screen so that we see that something really is moving here. So I'll just make this a private function. I know that it has to be suspending because we're using ktor to make the HTTP requests, and we'll just call this get images. And you can probably guess that that returns a list of bird image. And of course, I just gotta. Thank you very much. Look at that. So all we do is we grab our HTTP client and we'll make a GET request to the endpoint of our API. So I'm just going to pop that on over here. And then all that I need to do to deserialize this, because I've already clicked together all the configurations, is I'll just say, give me the body of this, and I know that this is a list of bird image. Right. Matan is obviously already very eager to fix my code here, so he already added the return statement. I'll do him one better, and I'll turn the whole thing into an expression body so that we don't need parentheses at all, and we don't even need a return type. Nice and elegant.
That looks good.
Great. I'm glad you approve. So why don't you go ahead and maybe do something with this function?
All right. So first things first. So we are using a view model, which allows us to react to whenever it's cleared. So to make this just a little bit nicer, we can override the onCleared function here. And in there, we can grab our HTTP client, which has a close method, which just shuts down any still ongoing activity.
Good thinking.
So we can do that just as a bit of cleanup. And the next thing we want to think about is actually storing the result of this network call somewhere and then exposing it to our composable UI so that we can show it on the screen. So for this, we want some kind of state holder class. And what we'll do here is we'll create a UI state class. We'll call this just birds UI state. It can be a data class, and we want to store basically this list of bird images in there. And to actually hold an instance of this in the view model, we can use a state flow so that it can be observed. And as it's changing, we can react to that from the UI side. The way we'll do this is by using a mutable state flow, placing in a bird's UI state there by default, and we can just start with an empty list while we don't have data. And this is going to be a private mutable version of the state. And then we can have a public variable which takes the same state object and converts it to a read-only flow so that users of the view model cannot modify it directly, but can observe it. And from here, we need to make a call at some point to the HTTP client and actually initialize our state. So we'll create a function for that, which we'll call update images. And in that function, we can use the view model scope that's provided by our view model superclass. We can create a new coroutine using launch. We can call the function that you've just implemented down here, which was called get images. And once we have the images, we can grab our UI state, we can use update on it to update its state, and we can take our new images and place those in there. So now if we call this from the UI, we are performing the network call, and we are storing the state in the state flow, and we should be able to show that on the UI side.
Wonderful. I suppose we could just go ahead and actually give that a try. So to do so, we'll first get rid of a little bit of the demo code that was previously in the app, and we'll instead do the following. We'll grab ourselves a reference to our view model. We'll make sure that we actually then update the images, and then we'll display the list of images somehow on screen. For now as text, and then we'll refine it as we go along. So first of all, let's grab the view model. That's because we use Moco MVVM, we use the get view model function, which takes a key and then a view model factory. Again, I can already tell that there's a lot of people with a lot of strong opinions in the chat here. If you're using a different implementation of MVVM, your code might look slightly different here. We're just choosing Moco MVVM for the demo. Great. With that grabbed, we can actually start a launched effect. which will key on the bird's view model. So this only ever changes if the bird's view model changes. And then we will call the update images function that Maton has built for us. Great. Then all that's left is actually displaying this. So I'll just for now use a text composable, I guess. And for that, we somehow need to access the actual state that's stored inside of the view model. We'll just kind of create our own variable for this, and we'll use the by syntax to use the delegate. So we'll use the bird's view model UI state, and we'll just collect it as a compose state. Great. With that done, we can have this UI UI states images maybe as a string and just display that.
And to prepare for this string being very long, we can already add a modifier on here. We can make this text scrollable by adding a vertical scroll. And for that, we need to pass in a scroll state, which we can create using the remember scroll state function.
Great. So let me just open this one up, for example, on desktop, just for a second here. We'll do that. I'm sorry, I ran that on Android. That was my mistake. But I mean, I guess
Android works.
Yeah, that works. That works just as well. But as you can see here, we now have the data actually already in our application. Isn't that nice? I did previously actually get the question of how do you run different targets on in Fleet, and the answer is, in the most recent versions, you can use just the run button, and you'll see that there are different run configurations automatically configured for you. So you'll see the one with the little bitten fruit. That's the iOS app. The Gradle icon is the desktop application, and then the Android is the Android application. So those are pre-configured for you. You can also create custom run configurations through the run.json, and in here you also get autocomplete to help you create your own run configs. Great. I mean, from here, since we now have the information, I think it's time we actually make things a little bit more visual.
All right, let's do that. So first, we'll remove the text that we've displayed, and we'll imagine a new function here called birds page, which will take our UI state as a parameter. Then we can go ahead and actually create that function, and of course it's missing a parameter. I can come up here and I can add a parameter. Of course, you can't see the intentions that I'm using here, but hopefully it makes sense. Am I making an invalid call here?
No, you're good.
Okay, good. So we're passing in the UI state, and in here we want an arrangement which starts with a column. Again, we'll have a row of buttons on the top and then a grid of images below that. So we'll just create that empty row here for the time being. We'll fill in the buttons later, and we'll focus on creating our grid. Now we'll want our grid to animate in and out as we are selecting the different categories of birds. So we'll use an animated visibility here, and we'll make the grid visible if the UI state has images in it. So we'll go UI state images is not empty. That will be our condition for the grid being visible. Of course, I missed some imports here along the way. And then the grid will be a lazy vertical grid. And for column sizing, we can use nice dynamic columns. So we can specify grid cells that are adaptive, and we can specify a minimum size, for example, of 180 dps. That should roughly work in our example here. Of course, I have a typo here in the parameter name as well. All right. Next, we can call items, which is how we can actually populate the grid. We'll choose the images from the UI state as the items, and we'll create a separate composable called bird image cell, which will take one of these individual images and display those. So let's create that composable, which creates an individual image on the screen. Again, we'll take an image which is a bird image as a parameter. And this is the spot where we'll use camel that we've added earlier for image loading and use a camel image. So the resource here will be an async painter resource. We have to pass in the URL here, which I think Seb will be able to help me with.
I'll bring that in. Yep.
Thank you. And once we have the URL, we'll add just a couple more details for styling for these images. So we have the content description, which is here for accessibility. We'll have a content scale, which we have to import, which makes sure that the images are cropped. And we are going to size these images to fill the width of the grid column that they're in. And we use an aspect ratio of 1, which will make them exactly square.
Great. Just for any viewers who are slightly confused as to why you're not seeing the little pop-ups with the autocomplete, that's because, of course, Martin is dialed in through the collaborative mode in Fleet. So those are things that happen on his UI. He sees all the autocomplete stuff. Great. This is, of course, a singular image. So we'll do that as is. That's all good. And I think with this, we can probably go for another quick run. So we can run this on multiple platforms just to give it a try. So for example, we might as well run it on desktop. We can actually just run it on all the platforms while we're already at it. So we'll just give this a moment. Really giving the machine a good workout here, building 3 things at once. And we can see that we already have a nice visual representation of all those bird images, which is quite delightful. We can also switch over to the Android emulator, and we'll see we have the exact same thing over here. So that's great as well. And the iOS emulator works the same way. Note that we try to make the application still feel very natural on each platform. So while I'm just scrolling with the mouse wheel on the desktop application, if I'm on Android, I'll get the nice little overscroll effect that's slightly stretchy over here. And on iOS, I get the nice spring effect that people might already be used to. Great. I see that, Martin, you already had a couple of aesthetic changes that you wanted to make here.
Yes, just as we were looking at those, I've added a couple more modifiers here and there so that we have some nice spacing and some padding between these images. So if you rerun the app on one of the platforms, we'll see that we've added, again, just a bit of styling, some arrangement, some alignment, so that, the images have a bit more room to breathe.
Very nice. Beautiful. And I mean, this could almost be our done application. But we did notice in advance that we do have a category and that we did want to build a category selector for those, because right now all those pigeons are mixed in with all those eagles are mixed in with all those owls. So I think we can probably do something here. The way that I'll approach this is I'll just start kind of writing a little bit of the code of how I would imagine this to be, and then we can fill in kind of the missing parts at a later point. So Martin already gave me this nice row where I can have a couple of buttons next to each other. So in here, I can just, for each of the category in my, I would assume this is a part of the UI state, and it would be called category. So these would just be strings. I could create a new button. So this button does a couple of things. It'll have an on-click modifier, which probably should do something like on-select category with that specific category, and we'll bubble this up. So we'll have an on-select category up here, which is a function of string to unit. So it doesn't have any return type. We also need to specify the content, which is just the text, which is the category name. So let me make sure that I import that composable as well. And while we're at it, I might as well make sure that those buttons look semi-presentable. So first of all, let me compress this code just a little bit and add a modifier that first of all makes these buttons square, like we saw in the original image. So they'll have a aspect ratio of 1.0, and they'll all have the same weight, which means that they are kind of the same size. Now, observant viewers will have noticed that the code that was previously red suddenly turned purple. And this, of course, was once again done through the magic of collaboration. Because while I was typing out this code, Matan was busy working in the view model, already implementing the functionality for the category selector. Matan, do you want to walk us through what you've done here?
Yeah, let's see that. So the first thing I've changed here is up at the very top, where previously our UI state only stored our full list of images, which contained all of the images that we got from the API. The other primary thing we need to remember in our UI state is the currently selected category. So we have a property for that now, which is null by default, so that we can also have an empty selection. And then we have two new helper properties here, which compute the categories, which just takes all of the different categories that occur in the list of images and puts them into a set for us so that we can iterate it and create the buttons on the UI. And we also have a new property here, which will be a list of images, but filtered to the currently selected category. So if we update the selected category from the UI side, then we can go ahead and start using this to populate our grid. And to perform the update of the selection, if we scroll down a bit more, we'll see that we have a select category method now, which takes a string as a parameter, updates the UI state, and the logic here is just that if the category that we've tried to select is already selected, we'll clear the selection, and otherwise we'll make that the selected category. So this way we can enter a category, and if we select it again, we can also get out of it and clear that selection.
Great. Now, tooling is already quite helpful here because it tells me that this property, the selected images property, is not used, neither is the select category function. So I still have a little bit of work to do. So let me just head back on over into the app. First of all, we do have a little bit of red code here because it says I didn't pass a parameter for on select category, so I can do that. All that does is it's going to take the bird's view model and it's going to invoke select category. If you're a function reference enjoyer, now is your time to speak up in the chat. I'm sure some people are like yelling at their screens at this point. And of course, the other part is making sure that we only show the images that are actually selected. This is used in two places. First of all, to determine whether or not we are showing images at all, and then the actual items of our grid. So I'll add that in those two places. And if I'm not mistaken, that should get us pretty close to what we would like to have in the very end here. So I'll just run this again on a couple of platforms. Just do Android and desktop, for example. And we'll see that we have our three buttons here. They're still looking mighty purple, but we do have the buttons. We can click them. We'll see that they each select and lazy load images of the specified category, and we can still scroll, and we can also still close them with a nice little animation. So that works wonderfully well. Excellent stuff. I think we could probably make it just a tiny bit nicer, though, at this point still.
We certainly could, and an easy way to do that is by modifying the theme that the application uses. So just a moment ago, if I undo here, we can see that the default theme was a default material theme for the application, but we can just wrap the entire application in our own theme instead, which if we take a look, I've created up here at the top. So this also uses a material theme, but we are customizing the default one so that instead of that purple accent, we have black as our primary color. And we're also customizing the shapes so that instead of all of the rounded corners, we can have just 0 dp, like sharp corners.
Very nice. And then if we'll rerun this on, I suppose, all of our platforms, because I think this is about as far as we'll take this app today. We'll take a final look, and then hopefully we'll get something that looks quite similar to those screenshots that you've seen in the beginning. So here we have the iOS version, we have the desktop version, and we have the Android version of our application. And each one of these will load images just as you would expect them to, and can show those nicely on each platform. Even though we only built the UI once, I think we got pretty far for the time that we spent here. So let's kind of collect our learnings here, move back to the presentation, and then dive into a couple of slightly more advanced topics. So thank you so much for sticking with us through that live coding section, because we've seen a lot of different things here. We've created a entirely new project using the Kotlin multi-platform wizard. Then we've made sure that our development setup was correctly set up using KDoctor, the command line tool. We've used a bunch of different multi-platform libraries, and we'll talk more about multi-platform libraries in just a little bit as well. We've built the UI entirely in Kotlin and in Compose multi-platform using APIs that are already pretty well established. And we ended up deploying it to Android, iOS, and desktop, and we were able to rather quickly iterate during the development process, all while collaborating, which I think was a great time. Cool. With that, I want to bring a short spotlight onto Compose for iOS specifically, because that's usually where a lot of questions come up. We're not going to dive too deeply into this. If you want to get like an in-depth view of the technology behind this, I invite you to watch the Kotlin Conf talk that I gave together with Nikita, which is called Compose Multiplatform on iOS, where we dive in a bit deeper. But just to cover the most important topics, when you're building mobile applications, or when you're building applications in general that are UI heavy, oftentimes you want to be able to integrate with the capabilities that the underlying system has as well. So that includes things like, for example, interacting with the camera, or adding web views, or, for example, map views. Compose multi-platform allows you to interop with all of these out of the box. So we have this wonderful adapter function called UI kit view, and you can bring in any kind of native views, whether that's a video player, or a map view, or a camera feed through AV-Kit. All of these things work just as well on iOS. Martin also already briefly talked about this in the beginning, but one of the other cool things about Compose multi-platform is the gradual adoption. You don't have to go all in with Compose multi-platform on iOS right away. So you could, for example, just define a single screen using Compose multi-platform and keep everything else in Swift UI. That's powered by the fact that your Compose multi-platform projects are just exported as UI view controllers that can be consumed from an iOS application. So if you look at the screen on the right here, there's a compose view, which is like the chat bubbles and the actual background, and then everything else, the tab bar at the bottom, the navigation bar at the top, that's Swift UI. These things also mesh together quite nicely. So in this example, we have a floating Swift UI text field that is hovering on top of the compose part of your application, and that handles, for example, keyboard input just as you would expect it to. Compose multi-platform for iOS is currently in alpha. We announced it in alpha earlier this year at Kotlin Conf. You can kind of tell where we are, and it is our goal to make sure that Compose multi-platform for iOS is in beta somewhere in 2024, and because time moves linearly, Compose multi-platform for iOS will be stable sometime after we hit beta. Now, it's important to note that Compose multi-platform builds on top of Kotlin multi-platform, right? Which is really great because it allows you to use Kotlin native to get native binaries on iOS, which is amazing. But it also means that there's no magic switch where you can take an existing Android application and just turn it into an iOS application, like with a press of a button. This transition takes a little bit of work. Thankfully, with Kotlin multiplatform, you have all the tools required to make this transition. Expect an actual is built right into the language, and of course, the ecosystem has also grown quite a lot to offer you a large number of libraries that are already multi-platform.
And you've already seen us use some of those libraries in our demo earlier. And next up, we want to highlight some more of them so that you know that you are supported if you're looking to solve specific problems that are common in apps when you're using Compose multiplatform. We'll take a look at a bunch of different categories here, from image loading to navigation to resources, and then also some non-UI specific things, which are relevant if you're building an app. So first, we want to give a shout out here to Google, who are bringing some of their Android Jetpack libraries to multi-platform. So far, the collections, data store, and annotations libraries have been converted to have multi-platform support, and paging also supports multi-platform with an additional library from Cache App to actually add in those platforms outside of Android. This is great, and we hope that more and more of the Jetpack libraries will become multi-platform in the future, as if you're coming from the Android side, you don't even have to look for alternatives to libraries in these cases, because you can keep using the same libraries that you can use on Android and that you already know. Moving on, we have a couple libraries for navigation. For example, there's Voyager, which is built specifically for Compose, and it offers things like type-safe navigation between screens. There's also Pre-Compose, which again is Compose multiplatform, and it closely models the Android concepts for navigation. So it has lifecycle, view model, and so on. So you might find that friendly if you're coming from Android and Jetpack. We also have a whole suite of libraries from Moco. You've seen us using the MVVM library earlier to have a shared view model. There are also libraries from them for permission handling, for biometrics, for media, as well as for multi-platform resource handling. So these are also something that you can choose to use. For image loading, we've used Camel, which was, again, just a choice of some of the available libraries. There's also Compose Image Loader, which is multi-platform image loading implementation. And we have Coil, which is not multi-platform yet, but it's a really popular library on Android, and they have received a grant from the Kotlin Foundation to convert it into multi-platform. So we're looking forward to seeing that come to the multi-platform ecosystem as well. Now, I want to mention theming next, because by default, as you've seen here, Compose multiplatform comes with the material theming, which is the same as on Android with Jetpack Compose. So you can choose to use that theme if you're building for multi-platform. You can also choose to use the lower layers of Compose and build your own theming system on top of Foundation. And there are also community libraries out there that provide some theming. For example, there's the Compose look and feel library that you can see on the screen here, which offers a Cupertino-style widget implementation and theme for Compose, meaning that if you want your Compose apps to look more like native iOS applications, you can choose to use this library and have different theming on different platforms. Now, for some things that are not necessarily UI related, or well, not UI related at all, but are really useful in your multi-platform applications that you're building, we wanted to highlight that we have great networking choices. We have Ktor, which is a first-party library for both multi-platform client and server implementation, which you've seen us use in the demo as well. And that's an HTTP client. While you can also have a higher level API with a community library called KtorFit. If you've used Retrofit on Android before, you'll see that KtorFit is emulating the same idea of annotations on an interface and then having implementations of that provided for you automatically. We also have several options for persistence. So we have SQL Delight, which offers you nice structured storage using SQL on multi-platform in a multi-platform library. We also have KStore, which can serialize Kotlin objects using Kotlin X serialization into files. So for simpler use cases where you don't need structured data, you can choose to use that. And we have multiple options for key value storage. So we have multi-platform settings, which has been around for quite a while. It's one of the older multi-platform libraries. And we also have data store, as already mentioned. So that's a Jetpack library that has been ported to multi-platform. Finally, just to wrap up the library tour here, if you're ever looking for anything else that you want to add to your multi-platform application, the KMP Awesome repository is a great place to start. You can check out its README and you'll see that there is a large collection of libraries that support multi-platform. So if you need to add logging or dependency injection or testing or some architecture library to your multi-platform application, you can take a look at a lot of the available ones in this repository easily. At this point, we also want to talk to the authors of libraries here for a moment, because if you're creating a Kotlin library, we would really like to encourage you to consider making it multi-platform if you don't have very, very strong dependencies on a specific one. And the same applies if you are building composables and shipping those in a library. You should also consider shipping those as a Compose multi-platform library instead of just a Jetpack Compose library. And the reason for this is that there is actually backwards compatibility between these artifacts. So if you, as a library author, decide to publish something as a Compose multi-platform library, then that will be available for consumers who are building their apps in Compose multi-platform, but also to consumers who are building only Android apps using Jetpack Compose. So these things are compatible, and this is a great example of Google and JetBrains working together on the engineering side to make such things possible. One more benefit that we want to highlight of using Compose multi-platform is, again, on Android, if you're targeting Android, Compose multi-platform is just Jetpack Compose. This means that if you build an application using shared UI on Compose multi-platform, and later on you decide that you want to stop sharing UI for any reason, and you want to go to a native implementation instead, you can actually take your existing UI implementation that gives you already a fully native Jetpack Compose app for Android, and all you would need to add at that point is the iOS implementation, for example, in Swift UI if you want to go with native, instead of having to throw away all of your shared code when you go from shared to native implementations.
Great. So we can also take a bit of a look at what's coming next for Compose multi-platform. One of the points that I've already also seen a couple of people ask about in the chat is multi-platform resources. That's obviously one of the big topics. Being able to easily load anything from files to images to fonts across all the different platforms is something that we are currently working on. We're also working on making the test APIs entirely common, as well as providing common preview annotations so that you can see previews even for code that is not platform specific. On the iOS side, we're still working on some accessibility improvements. We also want to make sure that, for example, zoom settings are respected, as well as contrast preferences are also applied to your projects. One of the big topics, navigation principles and lifecycle management, is also something that we're looking into. I can see there's a lot of strong opinions over in the chat on this as well. So rest assured that this is also something that is on the roadmap. With the big step of Kotlin 2.0 just around the corner, the team's also hard at work in making sure that K2 is supported in its entirety so that you can use it for your Compose multi-platform projects. Great. With that, I believe it's time to say it is your turn. If you are an app developer, it would be awesome if you would go out and experiment with Compose multi-platform for iOS, Android, desktop, or whatever constellation of platforms works for you. And if you are a library developer, it would be awesome if you considered supporting Kotlin multi-platform and Compose multi-platform. To start your own learning journey, we have collected a number of different samples in the Kotlin multi-platform samples page on our development portal, which you can find on jb.gg/KMP samples. These come with a bunch of first-party example apps built by us and the Compose team. For example, the image viewer application, which you may have seen across a couple of our other talks, the Composer chat application, which demonstrates Swift UI integration with Compose, and a couple of other ones. But it also includes a bunch of different projects that were built by the community, because people in the Compose multi-platform community have been really hard at work since the first official announcement, and honestly even before that. And they've built anything from like demos to like side projects to fully working applications that are available on the App Store. So those are definitely also worth checking out. The easiest way to get started is to go to jb.gg/compose, which will bring you to the landing page. We also very much invite you to join the Compose-related channels on the Kotlin Lang Slack. Make sure you join those if you haven't yet. We have a general Compose channel for everything about Compose, but we also have a couple of channels like Compose Desktop, iOS, and Web, where you can talk about those specific targets, ask your questions, or just hang out with fellow Compose developers. At this point, we would also like to shout out the rest of the live sessions that are going on. You've already now potentially seen 3 of them, with one more upcoming on November the 30th. That is the iOS development with Kotlin multi-platform tips and tricks live session. That one will happen at 4 p.m. UTC. Have fun converting that into your own time zone. If you do sign up on the link, I think it'll automatically tell you what that is in your time zone. And as we've shouted out beforehand, later on in December, we will also have the Kotlin and WebAssembly live session, where Salim will talk a little bit more about topics related to that. Great. So with this, we of course hope that you'll give Compose multi-platform a shot and hopefully have a lot of fun with it. I assume, since with my presentation setup I couldn't see the chat for the last 15 minutes, I assume there's a couple of questions, so we can go ahead and we can answer a couple of those. And I'll try to see.
We have indeed a lot of them.
Great. Now that's just delightful. Okay. Why don't you? Do you have a question that you would like to kick us off with?
I don't have controls to pop the questions up.
Great.
So
then I'll do that then. Sure. I'll not do this in any particular order. The first one is, can we please get a link to the slides and repo? And the answer is yes, you can. We'll make that available right after the event if you've signed up prior. Otherwise, you can take a look at our, or I suppose at my GitHub, where this will be published momentarily after we're done here. That's great. We'll move on here. Let me just pull this up. Any plans for a Firebase library? I'm trying a project using GitLive Firebase. Yeah, so you've already chosen the library that's currently out there. We're hoping that the Firebase SDK, just like a lot of other libraries are currently moving to Kotlin multi-platform, will be KMP eventually, but that would be up to the Firebase team. Not so much us.
Let me do a question without highlighting it. There was a question about Fleet being available or Ubuntu, or will it be available in the future? It should already be available for Linux. So go to jetbrains.com/fleet/download, and you should find it there for Windows, macOS, and Linux, just like that. There's a picker up there. Yep.
Yes. Wonderful. Great.
You'll also need the JetBrains Toolbox app to get it installed.
Which is this one up here, built using Compose multi-platform. Great. what is the risk of Apple blocking apps created in KMP and Compose multi-platform to be uploaded to the Apple store, or I guess to the App Store? It's an excellent question. We don't foresee any such risk. It uses the same approach, or other frameworks that allow you to build multi-platform applications have already been deployed on the App Store, very successful, whether that's like Ionic or React Native or Flutter. All of those, like, we're not doing anything particularly different when it comes to that. We're not making use of any crazy APIs that you're not allowed to do, or anything like that. It's also worth mentioning that Kotlin multi-platform applications have already been deployed en masse on the app stores. So those are already out there in production. We're also seeing a lot of our early adopters now bringing the first versions of their Compose multi-platform based apps, and we have not heard any reports with review issues specifically around the usage of Compose multi-platform. So I would not worry about that. Let's see what else we have here. How mature is Compose multi-platform with WASM and WebGPU? That's an excellent question, but it's slightly probably beyond the scope of this chat. We do slap a very big label on it that makes it experimental if you go to jb.gg/compose, and I would treat it as such. So it's definitely the youngest target of Compose multi-platform, but yeah, this will still continue maturing over time. Great.
There was a question.
Yes.
Sorry, there was a question about with KMP you can't use Hilt or Dagger. Does that mean we will be unable to use those libraries in the future? So yes, Hilt and Dagger. Thank you. Nice. Well found in that chat.
Thank you.
So yes, those libraries are tied to the JVM, at least for the time being. In theory, they could in the future add multi-platform support, but we know nothing about that so far. For what it's worth, you can use very similar libraries. I think Kotlin inject is quite close to what the Dagger is doing if you're building with multi-platform. And you also have other DI libraries with different approaches and different syntaxes to set things up. Again, if you go to the KMP Awesome repository, you can just search for dependency injection in there, and you should find several libraries that provide this. So as Seb hops over there, you can see that you have Coin, Codeine, Kotlin inject, and so on, just to mention a couple of the most popular ones.
Great. Tobias asks, on iOS, can I implement subviews in Swift UI as well? So anything that is essentially exported as a regular like UIKit view, you can also embed. Like, so if you have a view that's like a map or whatever, or if you build your own custom components, as long as those are regular iOS views, you can use those from Compose multi-platform as well. This is the warning that I always give, though. Please don't stack a Compose thing in a Swift UI thing, and a Compose thing, and a Swift UI thing, and a Compose thing. Like, the one level of nesting should be enough for hopefully most use cases. Just for performance reasons, obviously, and also so that you don't go crazy trying to manage state across too many individual parts. Great.
For the next one, there's when can we have Material 3 code in the common main source sets? I believe that should be right now. The wizard that we've shown at kmp.jetbrains.com currently generates the regular material library as a dependency, but if you just put a little 3 on there and sync the project, that should work.
That's right. So I think we can. I'll go crazy here, and we'll take a quick look here. If I go to the common main dependencies, I believe that if I just go to my implementation and I type in compose, there should be an autocomplete, and you'll see that we have Material 3 also supported, as well as the extended icon set, which is also good. So, you know,
which is important. There are a lot of useful icons in there.
There are a lot of icons there. Great. when is the WASM support becoming at least alpha? That is an excellent question. For that, probably Kotlin for WebAssembly would first need to become alpha itself, because that is already currently still an experimental technology. So we'll take it one step at a time, but things are progressing, the teams are working on it, and we are very aware that stabilizing these technologies is one of the big things for a lot of people so that you can adopt them.
We have someone looking for fleet tech support in the chat. I would like to point you to UTrack to file an issue if you are having any problems with fleet. It is currently in preview, so any feedback that you can give us is really, really useful so that we can stabilize it. So you can go to utrack.jetbrains.com, I believe, and report fleet issues there. Actually, utrack.jetbrains.com/issues/fl, but that's a bit long.
You just type in fleet up here, and then yeah, exactly.
There you go. Yeah,
We
so please
can
report issues
probably
there, or
also I'll try putting this in the chat, and we'll see if the spam filter decides that was not a good thing to do. We'll see how it goes. But yes,
I think it succeeded. Also, if you join us on the Kotlin Lang Slack, there's also a fleet channel where we are happy to take your feedback.
That's right. Let's see here. What else do we have? Are there plans for first-party support for look and feel? We are still in the phase where we're trying to figure out how important this is for the community, because we have honestly received a lot of very different feedback. I know that there's a lot of people who feel very strongly about having something that resembles the UI from each target platform, which is a perfectly valid position. But we've also heard back from a lot of people who say we have in-house designers that are building a corporate identity, for example, for our projects. So it is not relevant to us at all. Or if we're a small if we're a small startup, we just want to build a UI once and not have to care about whether it looks specifically native on each of the platforms. So if you do have feedback there, please make sure that you leave it in, for example, the Compose related channels or the Compose iOS related channels on Slack. We have the people responsible for all of the decisions in those channels as well. So they'll make sure to note down your view on these things. Martin, did you have another one?
There was a question. Well, there was a comment saying that it's amazing that UI can be shared so easily. Yes, it is. And the question following that was, is there a need to use Xcode still, maybe for publishing for iOS on the App Store? And I think we can say that yes, at this point, you would still need Xcode for some project configuration. And to like get things ready for publishing, because there are things that are really hard to edit like on the file level without using the Xcode UI. But hopefully we can make more and more things available for you to do without having to go through that path.
Absolutely. And as you saw, at least in the regular development flow that we went through, I didn't have to open Xcode here. I did have to open Xcode at some point on this machine to make sure that all the emulators are set up and like the Xcode command line tools are installed in the right place and so on and so forth. But there's a lot of the things that you can already do without ever leaving your IDE. This is especially nice because we also have a cross-language navigation, for example. So if I take a look, for example, at my app here, I click on this, I'll see that this is exposed as part of the main view controller. This is the export that we've talked about. And if I click on this, you'll see that I jump straight into my Swift files as well. So for a lot of the regular use cases, you can stay inside the IDE, but there are certainly, like Martin said, a couple of cases where right now you still need to use Xcode. Great.
For another fleet question, there's a question about how do I select the device to run/debug my code, and do physical devices work as well, or only simulators and emulators? So the second part of that is easy. Physical devices do work.
Yes. They sure do. And the other part is if you are in Fleet, for example, you just hit the run button, you get the pre-configured run configurations here. I can also copy this one, and we can see. So right now I'm using my phone as a camera, so it might not get picked up, but we can still have a quick peek here. Oh, you can actually see this. So this is my plugged-in iPhone called Akula at the very top. So I can also deploy to this. I'm not going to because I'm a little worried that my camera app is just going to like go and like minimize itself, and then I'll not be able to. You folks will not be able to see me anymore. But you can set this up, and you even get a nice autocomplete for this. Exactly.
Nice.
Great. Let's have a look. Oh yeah, this is actually once again a great question that Marcos asked us. What does it mean that you have to choose a library to show an image? Can't you implement it yourself? Do you want to talk about that?
I mean, you can implement that yourself. You would have to do the same work that the library authors have already done, most likely. Especially for doing it multi-platform. It's more work than probably what you want to do, but if you need very deep levels of customization in your image loading or caching, and you find that the existing libraries don't cover it, maybe it's worth building for yourself. But generally speaking, I think like on the app development level, you don't want to go down to the implementation details of something like that.
Yeah.
I assume, but it's up to you.
Yeah, like nothing would stop you from like using Ktor to just download a byte array and then use a conversion function from Compose Multiplatform to turn that into a bitmap. That would also work. But then if you find yourself hitting the typical use cases, like, I don't know, doing caching or like loading it, storing it on disk, downsampling the image to make sure that it's as performant as can be, all these kind of things, you can, of course, rebuild yourself if you don't want to use an external library for it, but it is something that these libraries just help you do. Also, during a demo, I'll take any help I can get. Any shortcut I can take, I'll happily take it. Great. We have I think very valid criticism point that we have already addressed, but I think it's worth mentioning once again. There's a lot of third-party architecture libraries, and it's a pain to migrate between them or to a native solution. It would be better to have a native solution for view models as for logic holders. And as we've said in the roadmap, I think it's a very valid point, and we're looking into seeing how we can best provide this so that this does not become a pain point for you.
There's a question on performance, which is there an IPC or any other potential source of slowness within Compose Multiplatform similar to the React Native bridge situation? Do you want to take that one?
Sure, I'm happy to. So Compose Multiplatform is rendered entirely using the Skia engine. I can already tell that a couple of people popped up or brought this up, so we can talk about this for a moment afterwards as well. But what you get is regular Kotlin native binaries. So those are real native binaries that don't do any kind of like specific interop with the UI system if you decide to build your whole application in Compose Multiplatform. So you should not see any kind of slowness there. That being said, we are working on and are committed to making sure that your Compose Multiplatform applications run smoothly in any scenario. So that means 60 hertz or 60 frames a second on regular devices and 120 hertz or 120 FPS on the more high refresh rate displays. One of the things that's currently limiting us in this is the Kotlin native garbage collector, which is currently being made entirely concurrent. So we're currently pushing down the maximum length that a garbage collector pause can take to something hopefully closer to like 2 milliseconds rather than what it is right now. So that should certainly help you never lose frames. If for some strange reason you find yourself with Compose Multiplatform underperforming, let us know. We are willing to fix this, and we want to work on that to make sure that your users get the best experience possible. Great. I also I think this is a very nice question, which is Ktor for the backend part of KMP? And it's a lit it's this is kind of a this is an interesting question because it's yes and no. So Ktor, if you actually take a look into its documentation, you'll see it's two parts. So there's a server part and there is a client part. And the client part is entirely independent on what server you use. In our case, we used an API that's just hosted on GitHub pages. Like this is just a static page, but we consumed it using the Ktor client. You could, of course, also write the actual API implementation in a real scenario using Ktor and then make full use of a coroutines-based API for that as well.
We have some good recent questions at the bottom of the chat. So there's a question about libraries, which is, shouldn't we be pushing for more platform agnostic approaches instead of pushing Android and Kotlin idiomatics to iOS developers? I think that's a great question. And as we were looking at our different libraries, you have seen that we see both of these approaches from the community. So we have libraries which are building for Compose first. I don't think it's worth avoiding Kotlin idiomatics because we are writing Kotlin after all. But if you look at a lot of these libraries, there are things that are porting Android concepts very closely. So they are very close to what the Android APIs are like. And then there are other libraries which are trying to do new and different things for Kotlin and for Kotlin Multiplatform. So I think the community is trying to figure that out right now. And it seems like these approaches can coexist side by side. And you can pick and choose which one is more beneficial for your use case.
Yeah. Then here's a nice one, which is, how would I start trying out KMM plus web? The KMP wizard doesn't allow web at the moment, and you're perfectly right. It's currently grayed out, but it actually does come with a quick link here, which says check out these examples on GitHub for how to use Kotlin for WebAssembly. So you can click on that. It'll send you to this example repository, which, as you can see, has pretty fresh examples here. And there's two examples in here: the Compose JetStack implementation and the Compose ImageViewer implementation. And I think, let me see if I can click on one of these or on two of these, and because you will also see that if you want to just get a quick view of how this works, you can just click it and you get the application running right in your browser. So this is a Compose multi-platform application. And you can do whatever you'd like with it. You can adjust it and see how you enjoy it. Great. There was one more question here, which was, hold on. Question about Fleet. Is the emulator the same one created by Android Studio AVD, or is it an independent emulator? Will I be able to use whatever tools in Android Studio, such as logcat profiling, etc.? Well, the answer is yes. Like, we can actually, if we pop open logcat here, you'll see that this actually attaches itself to the exact same emulator. And if I take out the filter, for example, you'll see that these are like all the messages that are coming from our application here.
We can also find these emulators in the device manager and create and manage them within Android Studio. So yes, it's the same emulators.
That's right. And fun fact, it is also the same emulators on iOS. So if you have, for example, the Xcode profiler or instruments and would like to use that on your iOS application, that also works.
There's a question about whether Room is getting a KMP version. So Room is a database library, which is part of Jetpack, so it's an Android library. If you take a look at the Google issue tracker, there is an issue that's tracking that, and there have been some commits, some change lists in that direction. Of course, as always with future releases, there are no promises of this, but if you look at the commits, there is definitely work going on to make Room closer to multi-platform, and hopefully we'll see it at one point.
Delightful. Since this question has now popped up twice, is support for Fleet on Windows in any way limited? The answer is not in any particular way. Like Fleet as a general IDE works on Windows the same as it works on macOS. That being said, of course, if you are doing iOS development, this is a limitation from Apple's perspective. If you want to run a simulator or want to deploy on a physical device, you need to be on a Mac. This is not a
Or
limitation
to
that,
even build a binary.
yeah, this is not a limitation that is Fleet specific. This is just a limitation that is well, Apple specific, I suppose.
We have a great question which relates closely to this, which is, would debugging Kotlin code on iOS work on Fleet? I think we can quite quickly pull up the blog post for KMP and Fleet.
Yes, we
that
can.
should work. So debugging is one of the features.
So yes, we do have. Actually, this is probably also a great blog post to kind of link overall. So I'll just put that in the chat so you can kind of get a good idea of all the things that work in Fleet already. And of course, Fleet is currently in preview. So if you find yourself trying it and find that something is either not working the way that you would expect it, or the functionality is just currently not available, make sure you head over to the issue tracker and you give it a vote. I can attest to you that there are people who are keeping a very close eye on all these things, and that your votes and comments 100% make a difference in where the technology goes and what gets prioritized.
Already answered, but yes, Material 3 is available for multi-platform, so you can use it in common main.
Yeah. Other nice question is, can we use KMP for TV development? That's a great question, and I believe so. Because at the end of the day, as long as you're targeting an Android platform, then you're just getting Jetpack Compose or just like regular Kotlin code, right? Like if you're just doing KMP. So there shouldn't be any big changes here for you to expect.
Yeah, for if you're targeting a TV and you want to use the TV specific Android APIs, then the amount to which you can do UI sharing will start becoming more limited, but Kotlin multi-platform in general will compile to a TV app.
Yeah. Where would you recommend to easily publish a KMP library? Jetpack is not KMP compatible yet. That's an excellent question, and I think at the current stage, the answer for this is probably you'll have to bite the bullet and go into Maven Central. It takes a little bit of time to get set up, but at least some of the stories that I've been told, like I have gone through the account creation process, which was actually highly automated in about 20 minutes. And then you just need to do a little bit of the extra setup, which of course takes a little bit more work. We hope that this will get slightly more streamlined in the future, but that's the current state of things.
Yeah. As a benefit, you also get some niceties from Maven Central, so it should be more reliable, have more uptime. You'll have signed artifacts, so you can trust them more. So it's probably worth investing into going onto Maven Central with your libraries.
Yes. Gabrielle says it would be awesome to see an NPM-like repository. I agree that it would be lovely to make the publishing workflow as easy as possible, and we're working hard to make sure that it is smooth. But what those solutions look like in the end is still an open and undecided question. Here's a very nice one. Any efforts to help simplify project and Gradle configuration? A KMP project can be a bit overwhelming about what and how to use the different Gradle files. Do you want to take that one?
Yes, we do have efforts in that area. Let me throw the blog post into the chat as well. So we have a tool called Emper, which is a project configuration tool built on top of Gradle, which aims to address this exact thing, that configuring a KMP project can be quite complicated. And you can see some samples of that on the screen right now. If you scroll down a bit more, we can see, for example, what the build configuration for a multi-platform library module can look like. So this would be a library. It targets JVM, Android, iOS. It has some common and some Android-specific dependencies. And then we have some settings for multi-platform at the bottom, like enabling serialization or enabling compose for all of these targets. So this is something that's still very experimental, but we would really love for you to check it out. The best place to go is probably the blog post for the initial encounter, and then you can head over to the GitHub page of Emperor, which contains a lot of detailed documentation, as well as an examples folder, which contains a handful of example projects that you can check out. And you'll find that all of these contain very, very brief module configuration files.
That's right. So if we look, for example, into the Compose iOS example and we'll click the module.yaml, you'll see that this is probably a little shorter than what you're used to for your configuration files. It's as easy as saying, I'd like to have Compose Foundation and Material 3. I'll make sure that the Compose integration is enabled, and then potentially you have some kind of configuration that's specific to iOS here as well. For example, can of course have a couple of different ones. So that might be interesting. Very nice. I'll pick this one real quick because it's a lovely topic. Does KMP support iOS device-specific features such as Bluetooth BLE support? The answer is absolutely yes. So you can use straight from Kotlin native code, so just straight from Kotlin code, you can use any kind of system APIs that are available on these platforms. Now, I don't know by heart the APIs for Bluetooth, but I could, for example, grab myself this UI device, which, as you can see, if I hover over this, or you can see it from the import, comes from UIKit UI device, and I'll get like down here, I could use the current device. We'll see. We can pop this open here. So you can see that all the Objective-C classes that are available, those you can also use from Kotlin multi-platform. In a usual case, you would probably not even do this manually. Instead, you would use, for example, a library like Cable, which is Kotlin asynchronous BLE, Bluetooth Low Energy. And that is a multi-platform library that already provides you with a DSL. You can observe things in the form of flows and coroutines, and you can use that out of the box. So you don't even have to think about the platform-specific implementation anymore. I'll happily
it looks
also.
Like the library also has some fans in the chat, so
it sure does.
Feel like it's also tried and tested.
Yeah, so look at that. You're not the first one who's asked the question, and you're not the first one who had to answer it. So that's great. Go ahead.
There's a question about are there guides to convert an Android project to KMP? I've linked one of our documentation pages, which is exactly about making an Android application work on iOS.
We'll have a look if I can find this one quickly.
It's in the side menu. It's make your app multi-platform.
Let me just see here. Make your app multi-platform. There it is. So this is, it's make your Android application work on iOS. So this would hopefully give you the guidance that you would need for that.
And you've also done a demo of this, so we can probably point to one of the talks.
Hopefully. I am trying to figure out when I did this. So if you take a look at DroidCon Berlin 2023 and you click yourself through here somewhere, I don't know how I'll find the recording. We'll have a look. This one, I guess. This does have a video, so we'll put this in here as well if you would like to see me attempt a speed run of migrating things. And you'll notice I already feel embarrassed just talking about it, that there's a little hiccup in there. So you can enjoy that part. That's my gift to you for today. The other question that we have here, which is nice, is there support for location and camera-based application? 100%. So I'll preface this by saying if you're building games or AR experiences, Compose multi-platform might not be for you because you probably want to have the full extent of the just of the environment that you usually have. But if you look into our examples, so if you go to the, I'm now having too many tabs open. There we go. If we go through the get started page and we have a look at, or I guess we'll just go for the example directory directly. So if we go to the compose multi-platform repo, the examples, the image viewer application is what you can look into. And I think we have a slightly nicer screenshot somewhere down here. This application uses the camera view to take new pictures. And it tags the images with your GPS position, and it also shows it on a platform-specific map implementation. Google Maps, Apple Maps, what have you. So there is integration for this, and it works out of the box. You can use those examples to reference that.
Is there a list of available platform APIs like UI device? I don't think we have a list.
No, it's not a list, but I think the answer for this is you can go to you can literally go to the developer documentation on the Apple one. You'll even see that if you are in Fleet, for example, you can just click the open in developer documentation link on the quick help, and this will give you an overview here. So we can see here that there is a UI device. There's also a UI status bar manager and so on. So if I were to type UI stat, you can see that you get an idea of all the things that are available straight from the IDE or from whatever documentation page that you originally came from for the platform.
Yeah. So basically, all of these should be exposed to the Kotlin side. I think if you manage to find something that's not available from Kotlin, please file a ticket for it.
Yes, that's right. This one I like, again, because it's a call for feedback. Why do some Jetpack Compose animations don't work well in Compose multi-platform? If they don't, let us know. They should.
They absolutely should.
If you're hitting some hitches or the performance isn't as well as you would expect them to be, file a ticket. Give us a small reproducer or like a short screencast that says, "Hey, this is lagging on my device," and we'll get to it and we'll address it. We would be more than delighted to. We can also just briefly reiterate on this question. Oi, Seb, what about UI testing? That's what it says.
You had to, yeah.
Yeah, I had to, of course. The answer is, so the same test APIs that are available for Jetpack Compose, so for example, for awaiting an item to be on screen and emulating clicks onto actual elements, those are available as multi-platform APIs as well. There are some parts of that API that aren't 100% available yet, which is why you saw this in our overview roadmap slide to make sure that the test APIs are entirely common as well. Very terrible drawing here, but apparently I can't get around that.
Are there plans for first-party support for consuming libraries through Swift Package Manager?
I believe work on this is in progress. It's a very common request, and it's a very reasonable request. After all, while CocoaPods is very popular still, it's clear that SPM is kind of the way going forward. So we also obviously want to support that in the future. Work is continuing. Yes. We'll have a look here. What else do we have? Is it possible to reference an Objective-C written UI from the shared iOS main part in KMP? If you're talking about Compose multi-platform, you can embed those from your regular compositions as well. It should not specifically matter whether you wrote those in Swift or in Objective-C. Okay, another one.
I feel like we've run to the bottom of the chat at this point.
Okay, let me just check if there's something in very particular that we missed here. And I think we're also
anything else starred, yeah.
I think we've also very much exhausted our time here, but let's just see for some final questions. So a lot of questions that are about how can we use the underlying platform, right? I'm not sure if I can show more than one thing. What about SMS support? What about task manager, or what about background tasks, work manager? Um, you can use the APIs that already exist on the individual platforms. So if you want to do SMS, you can use whatever's built into the application. For most common cases, there are the multi-platform libraries. So I would once again direct you to, right after the stream, go to the KMP Awesome site, or the KMP Awesome repository, and see if you can find something that fits your use case. And I think you might be happy to find something there. Great. I hope that we managed to answer at least a large chunk of your questions. I know there's a couple of ones that maybe we have missed because there's a lot of messages. If you still have an unanswered question, I once again recommend you to join our Compose multi-platform related channels on the Kotlin Lang Slack, so you can get your answers there, hang out with other Compose multi-platform developers, and just have a nice time learning this new technology. And there you can also ask questions like, will we have previews for composables in common main source set? Yes, you will be able to. Awesome. Great. So thank you so much.
Sorry, just to highlight it once more, on the first session we've had last Tuesday, which was titled The State of Kotlin Multiplatform.
That's right.
We've also had a long Q&A afterwards. I think we had an hour-long Q&A with several people from the Kotlin team. So you might have had a lot of your questions answered back then as well. So that's always worth checking out.
Awesome. Great. And of course, this is once again then our final invitation for you to join the last live session on the 30th of November as well at 4 p.m. UTC about iOS development tips and tricks for Kotlin multi-platform. And then to go into December, we will have the WebAssembly live session as well with Zalim. So both of those, I think, are definitely well worth your time if you're excited about what's coming next in Kotlin. Awesome. Well, with that, I think it's time for us to say goodbye. You will see our faces in the future, surely. That is how things work. Thank you so much for tuning in. Very much appreciated. And we're, of course, excited to see maybe a couple of you in all the other social channels, maybe building your own Compose multi-platform applications. Great. With that, thank you so much. And see you at some point in the future. Take care, everybody. Bye-bye.
Bye.